reason all this stuff works. Okay? I remind you, if you have any mathematical expression and you multiply it by any other number of mathematical expressions, these are factors. When you do that multiplication, you get a product. So just to remind you of the words that we will be using in this unit. This is a product. Okay? Greatest common factor is the first one and the easy one. Now, I'm going to write something here that if you have been in my class before, you have heard me say. And I'm going to choose a fun color to make sure it sticks in your brain. Greatest common factor. Always do this if possible. If it's something that you should always do if possible, it means you need to check every single polynomial that you face and see if you can do the greatest common factor. Okay? All of you know how to do it. I'm going to quickly remind you, and I'm going to use light blue because it's fun and whimsical. The greatest common factor follows three steps. 1, decide on the factor. How do you decide on the factor? You must check coefficients and variables. Now, I am assuming that all of you know how to find factors. If factors make up a product and you get a product by multiplying, what must you do to the product to get factors? Divide, if you are going back that way. So I need to think of the number that divides into 6x and 3. What is it? 3. No x, because only the first term has an x. So I've decided on the greatest common factor. It is 3 in this case. That is step 1. Step 2. Divide every term by the GCF. So, it's 3. I'm going to divide that by 3. I'm going to divide that by 3. And step 3, write your answer. Answer thusly. You write the GCF, then a bracket, then you write all of the quotients that you got. Because this is a quotient. So, step 3, 2, I've divided by everything. Step 3, I take that GCF and I put it out front. And now I put all the answers. 6x divided by 3 is 2x. 3 divided by 3 is 1. Everybody remembers how to do this, yes? Literally, it's like one of the first actually complicated things that you learn in math class. But it isn't, you learn it in grade 10, but you really learn it in grade 3 when you learn fractions, don't you? Because really all we're doing here is the same thing you do with a fraction to simplify it, yes? So, what is my GCF in B? 2x. Because there's an x in both. So then I write the 2x out front. And then I write all my answers. 2x plus 3. Yeah? Yeah. Now, I am going to write one more here because sometimes I get students in my classes that go ahead. And they're like, I got this, no problem. So I'm going to write a slightly more difficult one over here. In what color? Pink? Fine. C. 12a cubed b squared minus 18ab cubed plus 9 A, B, C. Do that one. What goes well with pink?
Purple.
Purple? What is my GCF?
3AB.
3AB. So then I write my GCF out front, and then I write all my answers. What are they? 4 A squared B. 6B squared plus 3C. Everybody can GCF, yes? Excellent. Now, the problem that you people have when doing factoring is you do the GCF or you do one kind of factoring and then you think you're done. Okay? Whoever said orange. Always check if further factoring is possible. Always. So, now we move on to the second type of factoring. Again, you learned it in grade 10. This is a product, yes? Now, if you look back on your other sheet, you see that all of the trinomials broke down into two binomials, yes? Now, a great many of you have been taught how to factor these in a different way than I do them. That other way is wonderful. You are welcome to use it as much as you want. You do not have to do what I'm about to show you. But there's a problem with that other way, because when it gets to higher and more complex numbers, that other way is just a fancy form of guessing. And the ways I'm going to show you, you never have to guess. You always know the right answer. Okay? So you are welcome, if you know how to factor these on your own, you are welcome to factor them any way you see fit. But remember, when we get to higher, bigger numbers, most of those other ways are guessing. You're essentially guessing and checking for what will work, which often takes a lot more time, especially when there's a way that will work every time. Understand? All right. So this, we know if it is going to factor, because this is a product. If it is going to factor, it must break down into two binomials, right? And since we have an x squared, we know it's x and x, right? And since this is positive, we know that this has to be either minus minus or plus plus, doesn't it? Because at the end, when I multiply the L of FOIL, I need to get a positive number, don't I? Now, since this is negative, is this going to be plus plus or minus minus? Minus minus. It has to be. Now, all I need to do is find two numbers that multiply to 7 and add to negative 8. What are they? 1 and 7. Minus 1, minus 7. Done. That's how you factor those. Everybody cool? Yeah. Now, look at the second example there. What's different about it?
Negative and positive?
Nope.
3 is a...
There's a 3 in front of it. There was no 3 here, yes? Mm-hmm. I don't like that 3. So how do I get rid of it? I do the same thing that I'm supposed to do every chance I have. I do GCF if possible. So I see, can I get rid of that 3 by dividing by 3? Well, let's find out. Does that divide by 3?
Yeah.
Does that divide by 3? Yes, so I write it. 3x squared plus 6x minus 8. Now, does that look like that?
No. Oh, yeah.
Yes, it does. So if it's going to break down, it's going to be x, negative. So what do I know about the two signs?
It's going to be negative. The other one.
What do I know about these two signs? One has to be positive, one has to be negative. And if it's going to break down, I need two numbers that multiply to negative 8 and add to 6.
4 and 2.
What are they?
4 and 2.
4 and 2? What are they? Ayaka says they're 4 and 2. It's not 4 and 2, is it? Why? Because the signs don't work, right? 4 minus 2 is not 6.
Yeah.
2 minus 4 is not 6. So this looks factorable, but it isn't, is it? Right? What if I made this positive? Then could you do it? So now I'm not looking for negative 8, I'm looking for positive 8. Is that doable? What are the numbers that multiply to positive 8 and add to 6? Positive 4 and positive 2. Everybody with me? This looks factorable. But if it's not factorable, it's just as important for you to know when you can't do it as it is for knowing when you can. Because if you think you can factor it, and you continue to factor it because it looks like it's factorable, you haven't done the work right, have you? Now, the thing that's nice about factoring is you can always check if you've done it right. So, for example, if we actually did Ayaka's thing where it was plus 4x minus 2, we check. X times x is x squared. That's good. Negative 2x plus 4x. Oh, that's not 6, so I'm wrong. So you wouldn't give it to me, would you? Yeah. All right, you guys try a couple here, as always. Q squared, this will be, let's see, plus 16, and let's go with minus 17q. Do that one, and I'm going to give you another one. J squared minus 30k squared and plus plus 13jk. You try those two. And you can talk to your neighbor if you need to. This is not a test. Yeah, minus 30. I use JK so I could say just joke, just kidding. I wonder if the claps come out when I'm on my videos. It would be fun to see. Yo. I don't know. Let's check. Let's check. Yo, you only have one. Yes, you can. You go, guy. All right. What's the first one? If it's going to break down, it's Q and Q. That's positive, that's negative. So what are the signs? Negative and negative. And I need to multiply to 16 and add to negative 17. What are they? 16 and 1. Done. What about that one? What's different? It's going to be J and J, but what do I do about that? I got to have a K and a K, because that's how you make K squared. That's negative, so what are these two?
Positive, negative.
Plus and minus, and what are the numbers? 15 minus 2. Could I have 2 minus 15?
Yeah.
No, because that would not give me positive 13jk, would it? So you have to be careful. Everybody good? Score! Turn the page over. 52. Difference of squares. This is x squared minus y squared. And x and y can be anything. Highlight the word anything. We'll start with the easiest one possible. There's a lot of space here because there's a lot of ways this can mess with your head. X squared minus 1. Is that a perfect square? Yes, because it's x times x. Is that a perfect square? Yes, it is, because it's 1 times 1. Is that a difference? Yes. So the answer to these is always the square root of x plus the square root of y, the square root of x minus the square root of y. So, what is the square root of the first term? X. Plus, what is the square root of the second term? 1. And then you just write it again. Now that should be all I need to show you, correct? Like that should be it, right? All you should be able to do every difference of squares now, but I've been teaching math for 20 years and I know that that is not the case because this will mess you up a little. Let's see. What about this one? X squared minus 4. What's that?
X and 2.
X plus 2, x minus 2. Awesome. What about this? 9x squared minus 16. What's that? 3x minus 4, 3x plus 4. Okay. Does the plus and minus matter here? No. All right, what about this one? 9x squared minus 25y squared.
3x plus, plus 3x minus 5.
Good. What about this one? X to the 4th minus 9. X squared minus 3, x squared minus 3. Nice! What about this one? X to the 4th minus...
Mr. Mars, I think that's positive.
Yeah. Minus 256. Math, I am your father. And you're done, right? Of course not. Why? What's that? Right? Okay. What about this one? This one always blows kids' minds. X to the 5th minus X. Holy crap. What do you do, Deepinder? You take out an X, and then you get X to the 4th minus 1, yes? Then x squared plus 1, x squared minus 1. Am I done? Of course not. What is it? X plus 1, x minus 1. Bad ass. Everybody good? Now I'm really going to blow your mind, even though you're out of room. X plus 2 squared minus x plus 7 squared. Ooh, doggy. I'm going to give you a very powerful math gift right here in a second. Hey, since you three have so much to say, you must be able to factor this, right? So factor it. What's the answer? I'm talking to you three. I'm going to talk to them at the back in a minute. But you three are the ones I'm dealing with, because them at the back, if they aren't doing math, they're smart enough to have their pencils in their hands so they're able to fool me. Whereas you three aren't even trying to fool me. You're just talking with your pencils on the desk. Uh-huh. There you go. So how do I do this one? Here is your math gift. A equals x plus 2. B equals x plus 7. What can I write there instead of x plus 2? A squared minus. What can I write there instead of x plus 7? B squared. A squared minus b squared. Squared minus squared. So it's the square root of a squared, which is what? A plus the square root of b squared, which is what? B. And then I do it again. A minus b, correct? There's no a and b in this question. A is x plus 2, isn't it? So this is x plus 2 plus x plus 7. What's x plus x? 2x. What's 2 plus 7? 9. Then this one is x plus 2 minus x plus 7. What's x minus x? Gone. What's 2 minus 7? Minus 5. Done. This is a very powerful math gift. If you can use it, things get a lot simpler, don't they? Now, some of you cannot grasp this. No matter how many times I show you, it makes your life easier. I have students that I've taught grade 9, grade 10, grade 11 to. So 3 years I've been teaching them this move, and they don't get it. Do you have to do it? Of course not. You could recognize that the square root of anything squared is just that. There's the x plus 2. Right? You could also, and this is the worst thing you could do, but for some reason kids like to do it, you could have done this. X squared plus 4x plus 4 minus x squared plus 14x plus 49. You could have expanded them both, right? And then collected like terms. X squared minus x squared is gone. 4 minus 14 is negative 10x. And 4 minus 49 is negative 45. Yes? And then you could have factored that. Right? By taking out of negative 5. And then you would have had that. It's the longest way to do it, but it still works. Do I care what you do? Nope. And finally, now we're at the trouble spot. This is the one that will cause the most trouble for everybody. 3x squared plus 11x plus 7. What about that bothers you? You don't like the 3. We got a way to get rid of 3. We divide by 3, yes? Except we can't. Why not? Because 11 and 7 don't work with 3, right? Now, if you're from another country, when you're faced with this, a lot of you have been taught this move. You make a box, and you put 2 numbers over here that multiply to 3, like 3 and 1, and 2 numbers over here that multiply to 7, like 7 and 1. And then you cross. 3 times 1 is 3. 1 times 7 is 7. And you do all this weird stuff. I don't even know how to do it because I think it's useless. If you know how this works, you're allowed to use it. But I'm not going to show you it. Because here it's easy. Because 3 can only be 3 and 1. And 7 can only be 7 and 1, right? But it could be 1 and 3 and 1 and 7. You have to try all these different combinations to see which one works. Kind of like if you're doing a jigsaw puzzle and you turned all the pieces over so you could only see the back of it. You just keep picking up pieces and see if they fit. That's stupid. When you turn the picture over, you see the part you're working on is blue. You wouldn't pick up a green piece and try to put it in the middle of the blue, would you? Of course not. So there's a way to do this that always works, and there is no guessing involved. And I'm going to show you what it is. The reason you don't like this is because there's a 3 there, correct? If it was x squared plus anything x plus c, we could do it, couldn't we? Because we'd look for numbers that multiply to c and add to b, correct? All right, so this isn't x squared, it's 3x squared. So we like this, we don't like this. This is 3 times bigger, isn't it? Which means when I have this, and I'm looking for things that multiply to c, when I put this number out in front, I need things that are that many times bigger than that, don't I? So I don't need factors of 7. I need factors of 3 times 7. Because this trinomial is 3 times bigger than this one. Everybody cool? So, I need factors that multiply to 21. But they still have to add to 11. What are they? I did this wrong. It needed to be 10. What are they? 7 and 3. So I know that this is plus and plus. So it is x plus 7 and it is x plus 3, right? Because 3 times 7 is 21 and 3 plus 7 is 10. Everybody cool? Except it's not really 7 and 3 that I'm looking for, am I? Because the only reason I knew it was 7 and 3 was because I multiplied this by 3. right? When I'm factoring, I have to do some division somewhere, don't I? So the only reason I know that's 7 and 3 is because I multiplied by 3 at the beginning. So I better take that 3 out. Now, all you do now is simplify any fractions. Does that simplify? No. Does that simplify? Yes. That becomes 1. Once you have simplified, all the denominators move to the front. 3x plus 7 and x plus 1. And then you can check it. Is 3 times x 3x squared? Yes. Is 7 times 1 7? Yes. So we're right. The reason I like this method is because it keeps you doing a method you already know, and you always get the right numbers. You never have to guess. If you do that box method, you're guessing all over the place, especially if this first number has a lot of factors. Right? Like if I said, for example, 12x squared, let's go with plus, no, that won't work. 9 plus 31x. If you do that box method, how many options do you have for 12? Could be 1 and 12, 2 and 6, 3 and 4, yes? So you got to try a lot of different ones. But if you use my method, you know the 2 right away. Everybody cool? But if you like that box method and you learned it somewhere else, are you allowed to use it? Of course you are. Whatever works for you. So let's do this one. Can I GCF it? No. So I got to bring that 12 over here, and I got to multiply to 108 and add to 31. What are they? Is it 108 and 1? Is it 2 and 54? 2 plus 54 will get me 31 in some way. I would like to live in your universe. Is it 3 and 36? Is it 27 and 4? Yeah, sure, you betcha. So, what do I do with 27 and 4? It's x plus 27, but it's not really plus 27, is it? What is it really? 27 over 12, because the only reason I knew it was 27 was because I did this multiply at the beginning. And the other one is x plus 4 over 12. Now what do I do with every fraction I see? Simplify. Can I simplify that? What goes into 27 and 12? 3. So that is 9 over 4, correct? What's this one? 1 over 3. Once it's simplified, what do I do with all denominators? Move it to the front. 4x plus 9 and 3x plus 1. And then I can check, because it's factoring, so I never have to be wrong. Is 4 times 3, 12? Is 9 times 1, 9? If the ends are right, the middle's right. Everybody cool? Yeah, there's another method that also is a pain in the butt. Do you really want to learn it? Okay, Louis, it's called decomposition. You still have to do 12 times 9. You start the same. So it's 12 times 9. I need to still multiply to 108, and I still need to add to 31. I know it's 27 and 4, so then you write it this way. 12x squared plus 27x plus 4x plus 9. Then you group these. You factor that. What comes out of 12 and 27? 3x, right? So 3x comes out front, and I'm left with 4x plus 9, yes? Anything comes out of here? Yeah. It's a factor the factor that's common to everything. Divided by 1. So you bring out a 1, and that leaves 4x plus 9. Then you can see 4x plus 9 and 4x plus 9 are both multiplied by 3x and 1, yes? So they're both factors. So they're a GCF now. So we take them out. We divide both sides by 4x plus 9, 4x plus 9, cancel, 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 and I'm left with 3x plus 1. Decide which one works for you. You can tell by the fact that I was unhappy to show that I don't like it. Yes, Zara. I don't know, can you? Seems pretty close. Yep, you can. Good use of class time. Now, I remind you, everything is fair. All of these questions. So what if I gave you this? X plus 2 squared plus 7 x plus 2 plus 12. What would you do with that? There's a really long way to do it, and there's a really short way to do it. It has to do with the math present I gave you this lesson. What do you see there and there? They're the same thing, aren't they? So could I not say A equals x plus 2? Then what is this? A squared plus, what is this? 7a plus 12. That you can factor in your sleep. Multiply to 12, add to 7. What is it? 4 and 3. So it is a plus 4, a plus 3. But there is no a in the original question, is there? What is a? X plus 2 plus 4. What is a? X plus 2 plus 3. X plus 6. X plus 5. Everybody cool? This is a very useful piece of math. The reason I make such a big deal out of it is because I've started my math teaching career not showing kids that and hoping they would find it. They never ever did. I found it when I was your age. So now I give it as a gift. And even though I give it as a gift every year, still some kids refuse to use it. And they still expand this out, collect a million like terms, factor a giant polynomial, when they could just do that. Lucas.
What about the plus 12?
Okay. This will get me x squared plus 11x plus 30, yes? Okay. Watch. And all the rest of you, by the way, you can start working on page 53 and 53 to 55. You got half an hour right now. Now, Lucas, watch. I'm going to take all of this and I'm going to expand it. So that's going to be x squared plus 4x plus 4, yes? Plus 7x plus 14, yes? Plus 12, yes? X squared, 4 plus 7, 11x, yes? 4 plus 14 is 18. 18 plus 12, 30. See?